This is Pre-Calculus Concept 21A. We're going to be learning about solving exponential and logarithmic equations in some different ways. We're going to start off by solving exponential equations using like bases. So this is a pretty easy, straightforward concept that if you have an expression that says b to the m equals b to the n, then hopefully it's a logical thing that m and n must be the same amount. A quick easy example of this: if I had 2 to the x equals 2 to the 8th, it must be pretty obvious to you, hopefully, that x equals 8. So it turns out this is a really useful way for solving a lot of exponential expressions, which is what this lesson's all about. Alright, so let's look at two examples here. My first example, 2 to the 3x minus 8 equals 16. The key to solving this problem is to think about both sides of the equation in the same base. So it's pretty obvious on the left side that I have base 2, and luckily on the right side I can also write 16 as 2 to a power, so 2 to the 4th is 16. Once I have like bases, you can basically ignore them, no pun intended, and say 3x minus 8 equals 4, and all of you with your fantastic Algebra 1 skills can solve that problem. So 3x equals 12, and x equals 4. 4 is my answer. Always a good idea to check. So off to the side here, I'll do a quick check. 2 to the 3 times 4 power, 3 times 4 minus 8 power, right, should be 16. 3 times 4 is 12, 12 minus 8 is 4, and so I get 2 to the 4th, and 2 to the 4th is in fact 16. Okay, second example is a little tougher because 27 is not a power of 9, and so I can't quite take the same approach. However, if I look carefully at my bases, 27 and 9, you should recognize as both powers of 3. So 3 is the important base in this problem. 27 is 3 to the 3rd, so I'm going to write it that way. That's going to be raised to the x plus 3 power. And 9 is just 3 squared, and so I'm going to raise that number to the x minus 1 power. And some of your properties of exponents come into play here, back from Algebra 1, Algebra 2, that when I have a power raised to a power like I do here, that I simply multiply. Right? Don't forget to distribute. This expression on the left becomes 3 to the 3x plus 9 power. And on the right side I have 3 to the 2x minus 2 power. And there I've got my like bases. I can now ignore the bases and just focus in on what the exponents are. And here's my simple expression that I need to solve. 3x plus 9 equals 2x minus 2. Subtract 2x from both sides, and I get x plus 9 equals negative 2. And subtract 9 from both sides, and I get x equals negative 11. If I want to do a quick check, 27 to the negative 11 plus 3 power should be the same as 9 to the negative 11 minus 1 power. So 27 to the negative 8th equals 9 to the negative 12th. You could pull out your calculator and verify that, but those end up being equal amounts. Alright, we've got two u-tries here, very similar to the last two examples. If you need to rewatch those, do, but see if you can solve the first problem here. 5 to the 3x minus 6 equals 125. Alright, my key base here is base 5, so the left side of the expression is already base 5, and the right side can be rewritten as 5 to the 3rd. So the problem that needs to be solved, 3x minus 6 equals 3, 3x equals 9, and x equals 3. Hopefully you saw that as one of your options. Again, you could check your answer to verify. Okay, try this next example. Alright, our important base in this one is 2 8 is really 2 to the 3rd power, and 4 is really 2 squared. Right? So both of these can be rewritten in base 2. This becomes 2 to the 3x plus 6 power. This one becomes 2 to the 2x minus 6 power. And my expression that needs to be solved, 3x plus 6 equals 2x minus 6. Oops, 3x plus 6. And I get x equals negative 12 for my answer.